In this chapter, we're going to study trigonometry. In this lesson, we're going to use the cosine law to find missing angles.
Okay, hi everybody. So just like we were looking at with the sine law you can use it to find sides or missing angles. Same thing with the cosine law. But with the cosine law, the format is a bit different when you're looking for angles. With the sine law, they look the same, whether you're looking for the angle or you're looking for the side here. But with the cosine law, there is a substantial change here. So what I want to do is I want to just zoom in on this. This is what it looks like if you're looking for angle A. Okay? This is what it looks like if you're looking for angle B and angle C here. Now, what you should notice here is that when I'm looking for an angle, let's say I'm looking for angle A, I need side A, side B, and side C. So it turns out I need all three sides. In order to solve for an angle using the cosine law, I need all three sides here. And then look at the pattern here. You're going to see the pattern here. I've got two sides squared that I'm adding together, and then I've got it down here where it's 2 times b times c. In fact, the real link here is that when I'm looking for angle A, in the numerator I subtract side A squared. If I'm looking for angle B, I subtract side B squared up here. And then I've got the other two sides squared and added together, and then down here 2 times those two sides. And it's the same pattern here too. I'm looking for angle C. Up in the numerator I subtract c squared, and then the other two sides are squared and added here, and I've got the product of the 2 with a 2 there. So anyway, so that's how that works. And in each of these cases here, what you need to answer this problem are the sides. As soon as you've got all three of the sides here, you can find any angle you want using the cosine law. So let's just jump in and do some examples here so you get a sense of how it works. Okay, so in this question here, we're going to look for angle theta. And immediately I recognize in this problem here that I have got all three sides, so I know that I'm going to use the cosine law. And actually the setup is really straightforward here. So theta is going to equal the inverse cosine, okay, of... Now here I want to make sure that I'm really careful. It is so easy to make mistakes on the calculator here. So what I want to do here is I'm going to set up, just before I even get into this, I'm going to put more brackets here. Because honestly, I think this will help in the long run if you do it like this. So I've got a set of brackets around the whole thing for the cosine, the inverse cosine, and then inside that I've got a set of brackets for my numerator divided by a set of brackets for my denominator. I know that if I'm looking for theta, then I need to subtract up here. This needs to be minus 5.1 squared up here. And then the rest of it's just going to be 12.3 squared plus, oh, I did not give myself enough room. Oh boy, okay, I got to redo that. Okay, that was clearly not enough room. Oh, oops, my tape is falling apart here. Wow, all sorts of things going wrong with this one. So let's make this a little bit longer. Put brackets there, brackets in the bracket right there. So I'm going to subtract 5.1 squared up here. It's going to be 12.3 squared plus 8.2 squared up in the numerator. And then down here it'll be 2 times 12.3 multiplied by 8.2. Now, I can do this all in one step on my calculator. So I'm just going to let you watch what I do here. So first of all, second cosine to activate the inverse cosine. Now, that opens up a set of parentheses for me. That's this one right here. So I'm going to put another set of parentheses. That's this one right there. And now it's going to be 12.3 squared plus 8.2 squared minus 5.1 squared. I'm going to close the parentheses. That's this one right here. Divided by, and then I'm going to open the parentheses again. That's this one down here. 2 times 12.3 times 8.2. Close the parentheses, that's this one, and then close it again for the big one. Okay, and now when I press enter, it thinks about it, and I get the angle at 17 degrees. Okay, and I usually round angles to the nearest degree. Let's try that again with a different problem here. Now the numbers are different here, but again, I'm looking for theta here, and it's that 116 that is the side opposite. So my theta here is going to be the inverse cosine of, and if I'm going to give myself enough room, I'm going to put parentheses around the numerator and denominator, okay? And now when I fill this in, I know that up here, because that 116 is on the opposite side of the triangle than the theta, that's what I'm going to subtract here squared. And then I'm going to have 88 squared plus 165 squared, plug that in. And then down here will be 2 times 88 multiplied by 165. And now this is just calculator work. So let's take a quick look. So this will become the inverse cosine. Put another set of brackets for the numerator. So 88 squared plus 165 squared minus 116 squared. Close the parentheses, divided by, open another set. 2 times 88 times 165, 65. Close the brackets for the denominator, close the brackets for the cosine, press enter, and I get 42 degrees. Okay. That's how you use the cosine law to find an angle. Let's look at another example. Okay, so this problem reads, Nicholas has 3 pieces of wood that he wants to use to build a frame for his flower garden. The pieces are 12.2 feet, 9.5 feet, and 10.4 feet. Okay, so draw and label a diagram showing the triangular garden frame. Okay, well, we just need to throw a triangle down here. Doesn't really matter. Okay, we'll make this 9.5 feet, 10.4 feet, and 12.2 feet. And then we can call this A, B, C, just so that we have some names here. So we know that that's going to make this little c, that'll make this little a, and that'll make this little b. Okay? Now, the next question says, what will the measures of the angles be at the corners of the garden? Okay, so this is just going to be an application of the cosine law, right? Because we have all 3 sides, we're looking for an angle. So let's say we're looking for angle A. Well, we know that that is going to be the inverse cosine of, okay, and I'm going to give myself some room here. Okay, it's going to be the inverse cosine, and I know that up here I'm going to subtract, okay, I am going to subtract, and man, I hope I gave myself enough room. Oh, I can't find that. Well, I'll just use this one. I'm going to subtract the a squared here, so I'm going to subtract the 10.4 squared, and that's going to be 9.5 squared here plus 12.2 squared. And then down here it'll be 2 times 9.5 times 12.2. And I'll just go to my calculator. Let's enter that in. So that is going to be the inverse cosine, so second cosine, another set of brackets there, 9.5 squared plus 12.2 squared minus 10.4 squared, close brackets, divided by, open them up again, 2 times 9.5 times 12.2. Close the bracket, and I get, okay, we're going to round that to the nearest whole, so we're going to get 56 degrees there. Okay? Now, we're supposed to find all the angles. Let's find angle B. So angle B, same thing, would be the inverse cosine of, now I'm going to set this up, brackets around the numerator, brackets around the denominator. If I'm looking for angle B, then I need to subtract side B, which I know is going to be 12.2. So this is going to be minus 12.2 squared up there. And then this would be 9.5 squared plus 10.4 squared. And then in the denominator, 2 times 9.5 times 10.4. And now I enter that into my calculator. Whoops, make sure I can see that. So inverse cosine, another set of brackets. 9.5 squared plus 10.4 squared minus 12.2 squared, divide it and close the brackets, now divided by, open them again, 2 times 9.5 times 10.4, close the brackets, close for the cosine, oh, you can't see that, and then I get 75 degrees, okay, when I round that to the nearest whole. Now, part of the point of this problem right here is that once you get to this point right here, you shouldn't have to do a whole bunch of work to get the last angle here. We know that the angles add up to 180. So I know that angle C is going to be 180 degrees minus the 2 angles that I found here. So minus the 56 minus the 75. And that is a much better way of finding the answer here. Now you could use the cosine law and set it up again, but there's really no need to. So 180 minus 56 minus 75, and I get that that missing angle here is going to be 49 degrees.